Hi everyone, my name is Al Gakovic and I'll be doing a live coding session today. Hopefully this won't take more than an hour. We'll be programming a basic timer, very simple, that's designed to run every 3 minutes and 15 seconds, notify us and then restart on its own. We're doing this as a special event because it's the 20th anniversary of my favorite game, Phantasy Star Online Episode 1 and 2 for the GameCube. I've been playing it a little bit recently, and I noticed that something that would really improve my quality of life in the game is having a timer that's constantly in the background reminding me when to feed my pet. And the pet in the game is called a mag. So if I refer to something called a mag, that's what I'm referring to. So this mag timer will be the object of this project today. So I want to focus your attention on the main screen here. Forgive the video connection here. We're going to have some focus issues, but we should receive a sharper picture soon. The autofocus hasn't been the best recently. So going back to this main screen here, we'll move my music. We've got the Notion page for the project on the right. And I've set up a little Notion area here for the project, so the PSO mag timer. And in the Notion page I've just got some headers like research and feature list, and some areas for the footage that we can create. So in the feature list, which is the main objective of this little note-taking page I've made, so content calendar is the name of the folder I've set up in Notion, and the feature list is just a to-do list, and they're quite easy to make, and I highly recommend Notion for that reason. And the ones color-coded in red are features that we need to implement as part of the core of this project. It's what you might call the minimum viable product. So once these features are in place, the timer will run, and if that's what we need it to do, we can leave it there. And if we didn't want to personalize it anymore, we wouldn't need to. The timer would be complete, so to speak. The rest of the features are there so that the timer can be more personalized and improve our quality of life whilst we're using it. So we'll be going through these features one by one, and really the first thing that we need to do is set up a local environment. So we're going to do that first, and then we're going to upload we're going to create a remote environment on GitHub so that we can have a remote repository where we can add and commit all our data and progress on the project. So we can have also a place where the project sits outside of our local as a backup and as a way of sharing the project. Also a reminder to hydrate. During the process I also have my confidant here, so if I need to run any ideas through, Bob is more than happy to help, and he's sitting there waiting for me to ask questions. So first things first, we're going to open up a terminal. I'm using Windows today, but that's fine because I'm using a Git Bash shell. The Bash shell is not unique to Windows, it's in fact used on Mac and also on Linux, and so if you're on these operating systems, you can code along just fine too. So I'm starting by changing directory into a directory that I'm happy to work from, and projects is that directory for me. I'm going to be using make directory to create a new directory where we can work from today, and I've actually done that already. So mkdir mag timer has done that for me, and I've already made mag timer and it exists, so I'm going to change directory into that. And then the next thing we're going to do is git init. Now I've also already done this, but once you git init, it will create a local repository on the machine so that Git can be linked up and you can start pushing your data once you've done a couple of other things as well. So now that we've got a Git repository, we can check that it's there with list all files. The flag A does that, it lists all the files including the hidden ones. We've got ... and .git and .gitignore. So what we're going to do is, you won't have .gitignore, and frankly we can get rid of that for now. And we can get rid of contents as well. So this is all you should have at the moment. After the .git ignore, I'm going to clear my screen with clear, and we should be able to connect this up to a remote repository now. So we're going to navigate to GitHub. Once you're at your own GitHub, if you click the new button or the plus sign in the top right, from here, if you click new repository, insert a name, magtimer or something of the like. Magtimer is used. So we use PSO timer, and we create a short description. A personalized timer used to improve so this is not a title. Personalized timer used to improve quality of life. Okay, and we're going to make it public. We're going to skip these two steps for now, and we're going to create repository. So this is just a simple program, so we're not going to use a git ignore file or anything else. So this is a very useful screen that pops up once you've created a blank repository, like we just did. And it basically offers you a few options. So the quick setup I've never used, but we can essentially do one of two things here with our, well, one of three, but we're focused on these two. It's one of these two that we want to use. And so the first one is essentially if you are creating a new repository on your command line, or you can also use this one if you're pushing an existing repository from the command line. And since we have our repository in our command line, we're actually using the second one, but they're not all that different. In fact, the last two lines are exactly the same. And so all you're doing here is init, which we've already done, adding a readme. You're adding the readme that you've created in the first line, and then you're committing your first commit, and then adding a remote, this remote location linked up to your local, and then you're pushing up any your first commits. So we now need to link the repository from the command line. So we're going to git remote add origin hbs yes github.com/alex/pso timer.git, and fatal remote origin already exists because I've actually done this with my mag timer. So once you've done that on your remote repository, you shouldn't receive a fatal, and then we're going to git push up origin master. Everything up to date, and once that's gone through, you should be able to see that you have the one I created earlier. There we are. So I've deleted these two files. We can go ahead and add those changes and commit deletion of .git ignore and contents text files. Push that up to magtimer. Once that's gone through, we can see that there's now nothing in the repository, and we can continue. We're going to be using a Pomodoro technique timer. We're going to initiate the timer now. It's going to come in handy for our testing of our actual program timer, as well as the fact that having a 25-minute session is healthy enough to get into some work and also have a little break in the meantime. So moving swiftly on, we've initiated our local and linked that local to a remote environment. So now that we have a place to work from, we can continue with our program. So we need to essentially run a program. So the first thing we want to do is we need to create some kind of file where we can code our program, and I'll be trying to do everything from the command line today, from the terminal. So I'll be using inbuilt coding. I'll be using inbuilt I won't be using VS Code or Atom. I've forgotten what they're called now. That will come back to me, but you could use those if you please. I'll be using Nano, and in order to start, we're going to just call a Nano command to create a file called timer.py. So timer.py, so it's recognized as a py file, but we still we're going to create a little message here saying simple timer program for feeding mags. That's our message. This is what the program is for. So it lets people know what we're doing. The first thing we're going to just do is print hello. This is just for testing purposes. We're going to print hello with a capital H. And we're going to Control S to save that, and it writes all the 3 lines that I've entered into the program. And then we're going to press Control Exit. So Control Save, Control S, and Control X to exit. And now we've exited. We have a little program called timer.py here. Let's try and call it. Oh no, it's not command not found. Well, it's not command not found because you have to feed it an interpreter. It is a timer.py file, but it's not implicitly recognized by our operating system. In fact, it's recognized at the moment by a Python interpreter, which you might be able to call with Py, Python, or Python 3, depending on what OS you are and which Python you're using. So I'm just going to take the safe option here. I can call all 3, but I'm going to use Python, and I'll show you this. So Python timer.py, we'll call the program. The program reads that there's a comment at the top. It ignores the comment because comments are ignored in the Python language by the Python interpreter, and instead it reads print hello. So it prints us hello, and that's a simple program for you there. Python, as I said, Python 3 could also work as an interpreter, and also Py. Let's clear the screen and continue. So the very next thing we're going to do is we're going to edit that program so that the computer instinctively knows that it's going to need to use a Python interpreter to run this program. And the way we're doing that is we're adding a shebang or hashbang, which is a hash symbol and an exclamation mark. And that symbol sequence, followed by this path that I'm highlighting now, tells the system, the kernel that's running the program here, that it wants to look in this path for the program environment, and use the program environment to run the Python interpreter to read this program. So that's essentially what is happening when we call Python for timer.py. The environment program, which is a program that runs all the groundwork behind the scenes, make sure that all your environment is working, ties everything up, and runs things like your home, your print working directory, your profiles, your session data, and path, which is very important. And path is the magic thing here. This is essentially where the computer looks, all the places the computer looks, all the directories, to execute these programs. And in here we have user bin and user bin, which will come up later. Anaconda, which is interesting now because I'm going to show you where my Python is installed. It is installed in users Kamic Anaconda 3 Python, and if we look hard enough in this path, it will be in there because it's looking for the Python interpreter within this path, because at some point when things like Python are installed, when programs are installed, they are installed to places in the path that the computer knows to look for them. And so the environment variable is looking for Python, and it is telling the program to use Python to interpret the file. So that's what's happening here with the shebang line. Great. Now, we want our program to be executable by not just me, but also users that I give the program to. So in order to do that, we can change its permission by using chmod, change mode, which is the short form for change mode, and plus x to give it executable permission and call its name, timer.py. So adding executable permissions with chmod to timer.py. And I've input too many h's there. So now when we call the list of all files here and we show the long list, what we see is that for timer.py, the file is permission, so these are permission bits. There are exactly 10 permission bits. The first bit is a singular letter, either D or L or a dash. The D stands for directory, the dash stands for normal file, and the L stands for symlink, sympathetic link file. Symbolic link, sorry. Sympathetic is from a favorite book of mine. And then the subsequent bits come in sets of 3. The first set is for users, so these are the permissions for users. So if it's readable, there's an R where there should be a dash. If it's not readable, if it's writable for users, there's a W. If it's executable for users, there's an X. For the next set of 3, it relates to groups. So if it's the same for groups as it was here for users, it would be the same. But here it's not writable. These files aren't writable for groups. And here they're also not writable for global permissions. So this is group permissions. These 3 are global positions, and the first set of 3 are user permissions. And that's the important part here. Our user permissions and a group and global permissions are all executable. So timer.py is an executable file. And what that means is now we can just write in timer.py after the current directory and follow along. So it needs to know that dot wouldn't work because what you're saying there is so print working directory. What you're saying here is C users Kamic code, and then projects, and then you're saying mag timer. So that's what that just above here when we typed in .timer.py, that's what that looks like, timer.py, and that's wrong. We need a forward slash to separate that so it knows, and in order to do that we actually just use /. So the dot actually represents this folder, this file here in this place where you currently are. /. timer.py. And we'll run the program because it's executable now, and we don't need to tell it that it's Python anymore. We just need to run it. And it works because we have a shebang line that says use Python right at the top. Environment, use Python to read print hello. It's also executable by everyone. So that's the initial setup concluded, and we're going to exit, and we're going to add and commit these changes. Once that's pushed, we can start working on the core features for the timer. So, I've never written a timer program before. I'm really passionate about doing this for my game and increasing the quality of my life in the game. So we're going to ask Google how to create a timer program in Python. Okay, Stack Overflow. First answer up on Google. Let's have a look. So we're going to check it out. This person is saying they are making a timer program, and down here there's an answer. It seems a bit fleshed out to me and maybe a bit too complicated. Let's look at anything. This is even more complicated. Let's see if there's anything a little less involved. Whoa, it's getting worse. This is a bit better, but I don't know if that's a better way. This seems like it would work. But there's a lot of stuff here that I'm not necessarily sure we need. Date, time. This is not working. So let's try creating a timer in Python. This is a bit better. This seems nice. There's a raw input, and while run start. Yes, okay. So if current seconds min print. Great. This is the answer. So here we're looking for something really small. This is even smaller and simple. Something small and simple. That's what we're looking for. Here, this is really small and simple. This is the smallest and simplest we've found. This is a kind of timer. Stop after the input minute run out. Alright, I think we can work with this. So we're importing something called time. I didn't even know that there was a library called time. Apparently there is. So with time, we call a method on time called sleep. Sleep 60 makes the program or the while loop sleep for 60 seconds, I imagine. So it's every minute. And then you can minus the minute by 1. So if you put the minute in for input, and let's say you feed it 3, the while loop plays until the minute reaches 0, and it minuses 1 every 60 seconds from the minute. So that's a timer for you. It's a simple timer. So let's take this code. We're not going to copy anything. We're going to put it in to our timer.py, replacing print. Import time. Minute equals input, and we're going to do this word for word because we need to know how this works before we can modify it to our needs. While min is more than 0, 1 2 3 4, print min 1 2 3 4, 1 2 3 4, whoops, print time dot sleep 60. We comment that, so that's every minute, and 1 2 3 4 minute minus equals 1. If you're not certain about what minus equals, it means the minute becomes 1 less. So the minute now equals 1 less. Minus equals 1. If you wanted to add a minute, plus equals. Very, very easy, nice way of saying add something to a variable. Add 1 to another variable. We're going to comment this to take 1 minute away. So here we have a very, very simple timer program. Apparently this is going to work. We call timer.py now. We've left out a colon where the while loop starts. So we're going to go back into our timer program and make it a bit more readable and add the colon that we so dearly need. Now we're going to call timer.py. And there is a syntax error here in this person's work. I can't believe I didn't see that, especially because I've written this out before. But print here needs to be written so. Okay, so this is going to, from what I understand, assign to minute or min whatever we input as an integer, because that's what int is saying here. Int is taking the integer of whatever we input and assigning it to min. And while min is more than 0, it prints min, sleeps the while loop for 60 seconds, and then minuses 1 from minute. So essentially the timer ticks down. Let's call the program, see what happens. Okay, we've been given an input prompt. The input prompt, let me show you here. The input prompt is telling us to add in the number that we want. We're just going to add in 2, and it prints the minute, and then we're going to pull up our alarm here. So we've just initiated the timer program at 40, so at 7 minutes and 50 seconds thereabout, we should see this print 1. If the timer is working, we should see this print 1, and then it should do the same again a minute later and finish. Yeah, the left window. Yeah. Sympathetic link. Name of the wind. Exactly, Ginger Tummy. Yes, exactly. I am streaming at the same time as recording this, so I'll be talking sparingly to my loving viewers, of which there are 4 now. Thank you for talking. Thank you for chatting with me. I'm very happy to have everyone here today. So we're about to see the timer print 1 now, because we have, there we go, we have a working timer. The timer is printing 1 because it's been a minute and it's slept for 60 seconds, minus 1 from the minute variable, and printed the minute variable at its new value of 1. So the next, we don't need to see this go through to the end. We're going to see many more of this in the near future. So we're going to keyboard interrupt with Control C to break from the program and head back into our program. So we have a timer. It's not the timer we want, but we have a timer. And the timer we want is a timer that allows us to input, well, a timer that counts 3 minutes and 15 seconds. We can't add in 3.15 here or 3.25 or whatever, because this is only taking in whole numbers. Integers are whole numbers, and it will not be happy if we give it anything after a decimal point. In order to give it something after a decimal point, it would have to be a float number. But even then, the timer is designed so that it only sleeps for 60 seconds and then minuses 1 from the value. So we would be left with 3.15, then 2.15, then 1.15. And then once we reach 1.15, we would reach 0.15 after it's minused 1. And what do you think will happen after it reaches 0.15? Do you think it will stop after 15 seconds, or do you think it would wait for 60 seconds more and go into the minus points, whatever? Well, it will. It would just wait for 60 more seconds. Your 0.15 would mean nothing, and you would end up with minus 0.45 or something like that. So this is not the timer we need. In fact, we don't need an input at all. We don't need an input because we know that we want 3 minutes and 15 seconds. Well, how do we make 3 minutes and 15 seconds count down? Okay, well here we're actually taking off. We're taking 60 seconds to sleep the program. So let's change that now to be more versatile. We're going to make it every second. So the program's going to sleep for 1 second, and then it's going to change something. Okay. If it already recognizes seconds, then maybe we can just add in seconds. So what about 5? So if we call this second now and make it equal 5, then we can print second, and we can make the while loop last until second is 0, and we can make time sleep for a second, and then we can make second minus 1. And we change these to seconds. Maybe that will help us out. We're going to save with Control S and Control X. We're going to call the timer 4, 3, 2, 1, 0. And the program exits. Great. We have a working timer. We have a working timer, and it deals in seconds. We're awesome. We made it through. In the last 4 minutes here, I think we should definitely commit everything to our GitHub so that we can save our progress. Working timer program. Great working timer program that deals in seconds. Very simple. We're going to push that up. And then we're going to have a look at our feature list. So we need this program to run for 3 minutes and 15 seconds. So 3 minutes and 15 seconds in seconds is however many seconds 3 minutes is plus 15. So 3 minutes is 180 seconds, and plus 15 is 195. So now, if we save that, the program should run for 195 seconds, printing every second, sleeping for 1 second, and then minusing a second every step of the way. Cool. Hello. Hello 3 minutes and 15 second timer. We love to check lists, and our first feature is complete. Great. Let's have a little break here, and we will come back after a 2-minute break. So please enjoy this music whilst I'm refreshing. Don't forget to drink water. See you in 2 minutes. Hi, welcome back. We are going into our second section now. We'll start our 25-minute Pomodoro. As we do, we like to work in lovely manageable times, and the timer will help us as we're creating our timer program. Our timer program is just finishing up, but we know that it's going to simply exit the program once it reaches 0. We'll do this just because it's probably visually nice feedback to know that we've created a simple timer program, and in 8 seconds we shall see that we're back in terminal as the program has exited. the while loop is finished because the timer has ticked below 1, and whilst the loop is more than 0, it runs, so the loop is finished and exited. Now we're back in terminal, and we can check that we still have our timer program. Everything is here as it is, and we can add and commit those new changes that we made just before we left. Change timer to work in seconds. Let's push that up. So, next feature that we need to implement is to notify the user when 30 seconds remains. Okay, so this one is a matter of using a conditional statement. So we don't need it to print seconds, but we'll keep it for testing purposes. At the moment, if we put some space in between there so that we can work with a new if section conditional statement here, we can add in an if condition, where if the timer reaches 30 seconds, if at any point sec equals in Python is an equals statement, 30, and then we need 4 more indents for the Python syntax to work, then we can print something like 30 seconds to go. Okay. We're going to test this just by running it at 45 seconds. We're going to save and exit and call timer.time. So we're printing every second still, just so that we can have some kind of a test system here. So at 30 seconds we should be able to see a 30 seconds to go warning. Wonderful. Alright, so we're not going to have the 30-second warning and also a 30, what's it called, a 30 we're not going to have both the 30 seconds notification and the 30-second tick printed. In fact, we'll just have the 30 seconds to go when the time is finished. In its state currently, we're just testing things. So that second feature has been implemented. So that's brilliant. So let's run a git add and git commit, add a 30-second warning. Perfect. So push that up. Great stuff. So this next feature, we're going to clear the screen. This next feature is really important. This is what we're going to react to when the timer has 1 second remaining, or when the timer is finished. I've thought about this a little bit, and in order to keep the program really simple and change the least amount of code, it might just be easier to run an if statement again that says if second equals 1, then play a sound. We'll pass just for now, because we're not going to add in a sound just yet. But I'm just going to talk about why 1. Well, if we were to pass in 0, the if conditional would never really come to pass, because the while loop is only happening while second is more than 0. So if second equals 0 will never happen, because this while loop would exit before second ever becomes 0. That's why we might as well call it 1. The difference between 1 second and 0 second is just a second. So it's not a big deal if this second is lost here. And in fact, down the line, we'll find out that we can actually add on this missing second into our timer, so all will be wholesome and complete again. So at this very moment, what we want to do is implement a sound when the timer reaches 1 second. Okay. So I have no idea. Let's go to Google. Google, how to play a sound in Python. Play sound using play sound. The play sound module is the simplest module to use for playing sound. Okay. Cool. Let's check out this Python tutorial on play sound. From play sound, import play sound, audio.mp3. Wow, that was easy. Okay. So apparently we need to import play sound. So from play sound, import play sound. Fine. Seems a little bit funny to import play sound from import play sound, but we're going to do that. And now we should be able to call play sound. Hold on. I know what I'm missing here. Let's open up a new terminal tab. Do I have play sound? Do I have play sound installed? Can we install play sound with pip? Not if you don't call it play sound. Alright, play sound. Requirement already satisfied. Great. So I have play sound installed. But if you don't, you will need to install play sound in whatever environment you're running. If you're running in a typical Python environment, pip install will work. Conda install might work too. Not sure if brew would work, but you get the idea. So make sure that play sound is installed. It is. Now I can import it from play sound, and I can ask it to play sound. So right, where are my sounds? Well, I don't have a sound. So what sound do I want to use? Well, let's have a quick look through my library here. So I know that Steam usually has some nice sounds. Let's pinch a sound from Steam. We're going to go into the Steam files. We're going to look up what games we have in Steam in common. Let's try Trackmania. Maybe it will have some nice sound. Game data, Alpine, media, audio, sound, waves. Alright, so we've got some wave files here. Let's see if this one is nice. Gotta turn the sound up. Here we go. That's fine. That's a nice little sound. We're going to copy that over, and we're going to go and head into our project directory, and in here we're going to enter mag timer. There's our timer.py, and we're going to create a new folder for sounds. We're going to keep all the sounds in this folder. So here's our first sound, and let's see if we can get another sound, because I know we're going to need another sound down the line, and I know this because, well, it's in our feature list. Here it is right here. Add a starting sound to know when the timer begins. Oh, that sound that we just found is a good starting sound. So we'll add that as the starting sound. I like it. But we actually do need a 1 second remaining sound. So the sound that notifies us the alarm is up. Excuse me, I need to sneeze. Sneezing over. Alright. We are going to find another sound. And why not find a sound related to the game? Great, sounds like a good idea. So we're going to check out the music that I have for the game. We've got some albums here, and I know that one of the albums is right here. I'm going to turn this down a bit for you. And we're going to check out the sounds here. So let's have a look at Rose Confession. Oh, that is a nice sound. we're going to use the first 23 seconds of that sound. Why are we going to use the first 23 seconds to notify us that the alarm is ready? Well, let's look at our feature list again. I seem to remember that here we need to buffer some time so that I can feed the mag. Feeding the mag takes about 20 to 23 seconds. It depends on what I'm doing. And having more time is better, so I can always be prepared to feed the mag and that the timer will never cut me short. So I will always have time to feed the mag if I buffer more time into the feeding process. So having an alarm that sounds for 20 seconds is good because I can be feeding that mag during that process. And that's very, very comfortable. So we're going to get a 20-second alarm, 24-second alarm, and we're going to put it into play sound. We're going to play that sound for 24 seconds. So that's what play sound's going to play. We don't actually have that at the moment, and so we need to make that, and we're going to go online to do that. We're going to use a tool. I'd probably find it in my history. We're going to find it in my history. Wow, this is very telling. We're going to trim audio in Windows, online MP3 cutter, audio trimmer, here it is. Is it an audio trimmer? Yeah. We can use audiotrimmer.com to do this quite easily. So we're just going to find this file, Rose Confession, in our Windows in our Windows folder, in our Windows Explorer. Should be in Music, Personal, Phantasy Star Online, and then here, and then in CD1, Rose Confession. So if we just drag that into here, we immediately gain access to the trimming sections. Trim to 24 seconds. Fade it out as well, so it's going to play for 24 seconds and fade out 20, 24, 25 seconds. Beautiful alarm if I may say myself. Really happy with this. Perfect. And we're going to crop that. Once that's cropped, we can download it, and downloading that brings it up here. We can show it in our folder, and we can cut it from there, wherever that is, and we can place it right back in our code directory where we're working. And of course, we made the sounds folder, so we can pop it in the sounds folder just along with the other sound that we want to use as well. We're going to close that down, and we're going to fold that there, and we're going to keep it up. So we've got 11 minutes left on the Pomodoro. We're going to install this play sound. Play sound. Play sound is going to want a path. So this could be a bit interesting. So actually we need the Explorer back up again. Play sound is going to want a path to the file. If the file was in the same folder as the program, which it is not, we could just write the name of the file. The name of the file being roseconfession audiotrimmer.com blah blah blah. It's not the same in the same path. In fact, it's here, and we're going to call it, we're just going to call it roseconfession.mp3. Okay, just to make it easier. So it's actually here. What did I do? Okay, alright. So we need to add the string, and then we create a string there as well. Sweet. There we are. So this is what it looks like here, the path to the file, but we're not quite done yet because we haven't added the actual name of the file. So we need to add the name of the file. You can do this with get file name. You can just rename and then copy all of that. You can add that onto the end there. Save that, and we're going to test this. So we're going to run a 20-second timer, and then now we're going to run a 5-second timer, and at the first second when it reaches 1 it should play the sound, and then I'll talk about why we're adding the full path here. Okay, so we're getting a syntax error, Unicode escape. The escapes, so codec can't decode bytes into 3 truncated. Okay. So let's go back into the program. It's talking about escapes. Why is it talking about escapes? Because this path is different to this path. It's trying to escape all of these words or characters in the string. So Python's backslashes are escapes, and they're used for escaping things like spaces and things like apostrophes or certain symbols, characters that are special and wouldn't usually work unless you escape them with a backslash. So we're going to switch the slashes to forward slashes and run the timer again. 5, 4, 3, 2, 1, and on the 1 we should hear music to my ears. So we've got our timer. And we've got our alarm. People, this is huge. Okay. And it should fade out. Wonderful. Ah, that's beautiful. Okay. We didn't need to press Control-C there. It actually ended the program. And that's an issue. We've got to discuss the issue of the program just ending. We want it to keep going. That's another feature. But before I do that, let's talk about why we have the full path here. We've got the full path here because the end goal of this project is to implement a feature called anywhere executability, and I call it that. What I mean is, if I open up a terminal spot, I don't want to have to navigate to projects and then mag timer every time I want to run this timer.py, right? No, I want to just open up anywhere and just run timer.py or timer or whatever mag. It's not nice. I don't want to have to, it's just annoying. So if I want to run the program from anywhere, I'm gonna need to feed play sound the absolute path to the file so that it knows where to find the file to play no matter where it is. Otherwise, if it's a relative path file, you'd have to be in the same place to run the program properly. So this is why we're using the absolute path file. So we can run this program from anywhere in our terminal. Anyone can run the program from anywhere in the terminal, and they would have so I'm not sure that they would have this work because it's currently hard coded to my user, but you get the point. So whilst I'm using this alarm for myself, we could run this alarm from anywhere in the thing, and it would absolutely find the path file every time. So we've got 5 minutes here, and we're going to save that, exit. We know that it works, and we're going to git add and git commit these changes. So excellent work. We've done quite a bit. We can tick off another. Feature, and then we can get started on these 2 features here. So we need to buffer some time in so that I can feed the mag. So this one is a tricky one. So I'm going to show you how this works out, because play sound is a bit tricky. Under the hood, what it's doing is it's actually doing something that we don't want it to do, but we can use what it's doing to our advantage. I'll show you how this plays out. So if we were to run a buffer, in order to run a buffer, we can actually just make it restart and run a buffer at the same time. We do this by setting the seconds variable at the top here to whatever we want it to be after seconds reaches 1. So after seconds reaches 1, play sound occurs, and we can reset variable seconds to whatever we want it to be. So let's say we want to reset to 5, so we just write seconds equals 5 here. And now we've reset seconds to 5 before the while loop is finished, and it never finishes. So the program literally keeps going on forever, and it will literally keep playing play sound on loop for 20 seconds forever. But we know that this sound plays for 20 seconds. We're going to add that as a comment here so people know. Sound file plays for 25 seconds. So it would be appropriate to have the timer reset to 5, because we just keep playing this sound over and over and over and over and over and over again. Right? Let's check it out. Does it work that way? Not sure it does. Let's see. Okay, first of all, our timer hasn't reset. What's going on? There's something weird going on here. So I had someone chime in from the chat in the last stream to tell me what was happening, but I realized this from my experience using Pygame. Their event that's happening, called play sound, is actually blocking anything else from happening until it's finished. So it's not letting anything else, any of the other following events in the while loop occur until the 24 seconds of playtime is over. So this sound plays for 25 seconds and it hogs everything. It doesn't want anything else to happen at the same time. So what can we do about that? Well, actually I think that's pretty useful. If we just exit out of the program right now and we go back into our timer and we check out what's going on here. So we've got a buffer of 25 seconds. So we wanted to feed our mag for some 20-second time frame, and for nothing to happen in that time, or for us to buffer some more time into the program, but we don't need to now, because we have a sound file that plays for 25 seconds and doesn't allow any of the other parts of the program to occur. What we can do is, let's say, have the program, if the timer we needed was 5 seconds, start at 5, take down to 1, play the sound, and while that sound is playing, we could just feed our mag. And then once that sound is finished playing, guess what? The timer starts again. And once that sound is finished, it starts again, we can feed our mag. And we have a buffer time. So we don't actually need to change anything here. We've got a buffer, and the program restarts on its own. Awesome. So we just need to make sure that the program is indeed set for 3 minutes and 15 seconds, and that it does indeed reset to 3 minutes and 15 seconds. But do you remember when I was talking about resetting the program, so when I was talking about losing our second here at if second equals 1, because we're not actually ticking down to 0, the timer's never actually ticking through 195 seconds, it's actually ticking through 194. So what we can do here to remedy that is make seconds 196, or we could make the reset 100. We can do both. We can make seconds 196 and we can make the reset. 196. So that was my alarm for the Pomodoro. We're going to take a small break here, 2 minutes. We'll be back in 2 minutes. Please enjoy some nice music. I'm going to put on the full track for Rose Confession for you. Enjoy. Hi, welcome back to Live Coding. I almost didn't want to stop the show. That was such a beautiful track. Rose Confession, everyone, from the Phantasy Star Online soundtrack. Please have a look on your own time. I love that jazz. So, back into the mode now. We're just going to open up our nanotimer.py. Nano being the code editor that we're using, that was the word I couldn't remember before. But you could be using Visual Studio Code, Atom, whatever other code editors you use. I'm just choosing to use Nano, quite similar to Vim, just as a way of working straight out of the terminal on this very basic program. So we're creating a timer here, and we've created most of the timer. We've got a timer that runs 196 seconds, which is exactly the time I need. At 30 seconds, it prints 30 seconds to go. At 1 second, it plays an alarm, a beautiful alarm, and resets itself thereafter to 196 seconds again. The thing is that the alarm doesn't let this reset happen until the sound is finished playing. Play sound blocks further events until the alarm is finished playing. But that's okay, because we actually needed some buffer time to feed our Mac, which was about 20 seconds anyway. I'm perfectly happy with leaving that play sound blockage in the program as a feature. It's unintended happy accident. An unintended happy accident, everyone. Sound like Bob Ross. Very good artist. I highly recommend checking him out. So we're going to check off that feature as well, and we're going to start on our next feature. Great. So we need to add a starting sound to know when our timer has begun again. It's all well and good that our seconds are printing now each time, but we're going to be taking that out at the end. We don't want our seconds to be printing. The less on the screen, the better. And so we just want to hear sounds. So if we want to hear a sound at the start of the timer, sure, we could add a if statement here. If second equals 196 play sounds, play whatever sound it is we want. But is there a better way to do this? I'm happy with this. So we're gonna run with that. We're gonna make play sound equal to the starting sound here. So we're going to locate that in our sounds file where we made our other sound appear, and we're going to copy over, essentially copy over the path that we are using over here, down here. We can copy in Nano using we use Alt 6, as it says here, M means Alt here. So we're going to Alt 6 all of that. We're going to paste it with Control U, and then we're going to snip off the end of that file, and we're going to add that file. So this is a WAV, not an MP3, but the play sound event should still occur the same way. So this sound is a lot shorter. I'm talking 1 second. This is 1 second. So this isn't going to disturb the flow of the timer much, but if you really want it to be super accurate, I would account for that 1 second it takes that we lose from the play sound event by removing a second from the timer. So now we have a timer that really does literally run for 3 minutes and 15 seconds and adds a buffer time of about 25 seconds for this alarm, for the feeding. We do need to add one little syntax bracket here, and we'll save that. I'll also note that I have added in some comments to let people know what's going on. Here we reset the timer to 3 minutes and 16 seconds, and I also changed these comments from seconds to second, and from seconds to second. Both of these were seconds before, plurals. Great. Okay, so we're going to test that, so we should run the program and hear the startup timer. Perfect. And as you can see, it does take about 2 seconds. We're going to run it again just to see. Takes about 2 seconds to play the sound. So we're going to actually factor that in to make sure that we are running a clean timer of 3 minutes and 15 seconds. So the timer is going to be 194 seconds. And we buffer in. We're taking into account the 2 seconds that this time is taking. And we're going to let people know that this sound file plays for 2 seconds. And we're going to tell them the exact time we want to run this timer for. We'll just add that comment in there so that people understand why we are running a 194 second timer here. And okay, that's good to go. So we've added the starting sound and that's working fine. So here we've got a feature that's essentially, that's my lunchtime alarm, but that's okay. So today we're gonna skip that alarm. We've added a feature here for 30 seconds to go. The notification might be an eyesore. Learn to clear screen between prints, or maybe consider ASCII art. So ASCII art is a nice thing to implement, but at the moment we're going to keep this simple. We're not going to implement that. What we might implement is the clear screen between prints, and I've been looking at it, how to clear the screen between prints. So you'd have to import OS. It looks like they're setting the clear for different OSs, but we just need clear. So perhaps we can call clear and let that be it. But we do need to import OS at the top for this to work. Maybe this will work. I'm not sure. Gonna give it a try. Want to adjust that so we're not waiting for 3 minutes on this. So seconds equals 31. Cool. Let's give this a go. This is just a test run. We're looking to essentially remove or clear the screen at 1 second. So that would be good if we can. Well, we don't have any problems syntactically. So syntactically, we are in the clear. Hopefully we can clear the screen as well. Looking good. 10:08. We should hear the 20-second alarm, and then we should clear the screen and reset the alarm. So we've got a 25-second alarm here, and then after the alarm, we clear the screen. And continue on. Once the screen is cleared, it will start printing out from 194 again. Okay, so there is an error. Once we reached the call clear, we got a name error. Call is not defined, and the program exited. So that's very interesting. So let's have a look at why call is not defined. From subprocess import call. Another way to accomplish this is using the subprocess module. Okay, subprocess import call. We need to import subprocess, not OS. So from subprocess. There we are. So since we're printing all sorts of stuff on the screen, we don't need this second to be 31. So it doesn't need to. We don't need to hear this. We can just print. We can just clear the screen of whatever's printed at the time, and that will be a couple of these digits. We can clear whatever's on the screen at the moment, hopefully. That would be very good, very, very good. A new feature that I have not implemented yet. This is brand new features coming to you from live coding on Al Gakovich's stream. Welcome, and have a nice evening. Reminder to keep hydrated. Very, very happy with that. We have a working clear screen processor. We're going to keyboard interrupt this program right here. We're going to go back into the program file, and we're going to wrap this up now. We're going to wrap this show up. So we've got a program here that runs for 194 seconds, which is technically 3 minutes and 15 seconds when you consider all of the buffer times and the playback times of these sounds. It rings a visual alarm at 30 seconds to go, and I've actually coded a better print, which I'm going to find for us now. If you just give me a second, nano mag. So here with the print that we access in this one, it's essentially the same program, but this is a more defined print, which I quite like. We're going to use for the processor of this particular. I keep trying to highlight and delete mass amounts of code at the same time, but that doesn't work. The cut buffer is empty. Hang on. So where is it? No. I wonder if we can just copy paste. We can just copy paste. Isn't that wonderful, everyone? We can just copy paste. Here we are. We've just copy and pasted this print. 30 seconds to go. ... Get ready to new line. Lots of commas. New line. Feed me. Lots of new line. Lots of dashes again, and end the print. So this time, when we reach 30 seconds, we'll print this beautiful feed me sign, and then again we're going to clear it just before we reset the timer. So visual warning. We don't need to comment that out. That speaks for itself. It's a visual warning. Don't over comment code, right? So we're going to just leave it at that. We've got our seconds. We've got our timer. We've got our excellent clear screen and 30 seconds to go. I saw the last thing to do is to make it executable anywhere. And in order to do that, we're going to just rename this timer. What have I done? Exit that. We're just going to check what I've done here. Yep, so we're going to just rename the timer program. mag. And we're going to rename it mag for a good reason here. Because we want to just be able to... Oh, don't do that, by the way. If you add in a line above the shebang line, the shebang line won't be read. The shebang, the kernel only reads the first line of any script to find the shebang process, and then it will read it from there. But if there's a line above it, it won't read it, it won't recognize it, and your program won't recognize it. It needs Python interpreter to run this script. So now that we have this program just called mag, it makes it much easier to run. We can... okay, so this is a different program. This is one that I coded earlier, guys. This is the one I coded earlier. And we're going to exit this, and we're going to take a look at why this is working now. So mag is working from before, and we're going to get this mag working. We're going to exit here because we have added mag to a place called home. There's the tilde key is the home path, and bin. Home/bin is a kind of makeshift place where you can just add your programs in. And in here I've got one called hello and one called mag. So the mag program is the one we've been working on, but hello is just a simple print username kind of program. So it returns hello, my name, my username. Mag is our program we made earlier, not the current one that we're writing now, and I need to remove it for that reason. So we're going to remove mag. Cannot remove mag. I can remove mag though. Cannot remove mag because there's no such file. There's no such file because it's gone. Great. So mag doesn't work because in this program there's no such file or directory. Now let's navigate back to our project. And timer.py is still there, but also mag. We can open up mag just to check that is indeed the program we're working with. So we can remove timer.py from the equation. There's no timer.py here. Does mag work? Mag doesn't work. The reason, as I say, mag doesn't work is because when we're calling things like Python just straight up from the terminal, what is actually happening is your environment program, the thing that's kind of linking everything up behind the scenes, is looking for Python in its path, which is here, which when you run the command which, you find out where Python is installed. It's looking for places in the path. Okay, ciao. Sve, imam recording sada, moram da... Ajde, pričat ćemo kasnije. Ćao. Hoću, kako da ne. Hvala puno. In the path file here, we've got all the places the computer would look for programs and executables. And in one of those places, I've added a location called home bin or user bin. And you can use either one, but I've chosen to use home bin. C uses Kamic as my home, and I can check that out by echo, and this $sign stands for the environment variable sign. If we just type in home, my home is C uses Kamic, and it's also the same path. So this is the shorthand for that path. C uses Kamic. C uses Kamic is all stored in this tilde key here that I'm currently accessing, and if I just add a slash and bin, well, it is a directory. See, it's a directory that I've created. You can create this directory by using mkdir home/bin. It cannot be created again because it already exists, but you can change into it once it's created, and therein lies the program hello. Now we also want to add in our program, which we've been making all this time, and so we're going to cd back into the directory that it exists in, and we're going to copy mag from the current directory, so that's the / current directory mag, copy it to /bin, home/bin. Once that's done, we can cd into we can show you some magic. Once that's done, as I say, we can just run mag. And the reason that works is because it knows to look for the program in the path, the environmental path variable. And once again, home/bin is a path variable that I've created. It's a directory I've created and added to the path variable. Now, I'm not going to go into how you add that to the path variable. It isn't that hard, and Google is your friend here, but you can definitely add that in a matter of minutes. And once it's added, you'll be able to actually copy any program you make. They don't need a name like .py or .anything. You can just call them whatever you want. And as long as the environment file knows which interpreter to use to run the script, it will be able to run the program from anywhere in your system. Before we were using // to run mag, and that still works, but now you can be practically anywhere you want in the entire folder system, the terminal system. So we can CD literally anywhere. So we CD back into projects where all my projects exist and still run mag, and mag will run. I'm just curious as to why mag isn't making a sound as it should be. We need to go back into mag and check that out. So what we're going to do is we're going to keyboard interrupt CD into home/bin where mag exists now, and we're going to nano mag to make sure something that should be happening is happening. Yes, so we left it on a testing phase. We have 194 seconds to modify here. That's fine. Nope, that's not fine. That needs to be 194 seconds as well to play the first jingle. Okay. Seconds starts at 195. The jingle plays for 2 seconds. Okay, so we just need to take 2 seconds off of here. And then once 2 seconds is gone from there, 195 seconds remains the amount of time the program runs for. We've got our 24-second long here, buffer time, we've got our 30-second visual warning, and we've got a... Oh. We've lost our... subprocesses. From subprocess import call. Actually, I don't like it being here. We're just gonna pop it down here. And once we've done that, we're also going to ask call to clear the screen for us, and then we're going to reset the timer. So sleep, and that all is happening under the while loop, and everything else has been explained. We can save this and we can test it now. So mag should be running accurately. Okay, we're just going to do one last thing here. I see what happened. We copied in the wrong file because, we copied in the wrong file, but that's okay. So we've got a different play sound. We're going to... I see what happened. Yeah, we've got the wrong mag file. So we're going to exit, and we're going to remove this mag file from bin. So there shouldn't be a mag file here at all. We're going to cd back into projects by opening up a new terminal. And this will wrap us up. So we're going to go back into projects, and we're going to go back into our mag timer, where our mag timer exists. Mag sounds and timer.py, and if we open up mag here we have our, here we have our subprocess import call. We're going to cut that and paste it down here. And we have our simple, 3 minute and 15 second timer. We realize that this needs to be 193 seconds so that we could make space for this 2-second file. We print this lovely visual feed me, and then we call clear. It resets to 193 seconds. And great, we're printing seconds as well. So we have this mag here that works, and we know that it works. So we're going to copy this mag file into our home/bin, and then we're going to run the program. So it starts at 193 seconds, waits for 2 seconds, and essentially it's a 195 second timer. Now we're going to let that run, and whilst that's running, we're going to do some cleanup around. I think actually we don't need to clean anything apart from perhaps the timer.py file, which is essentially the same thing with a couple of differences. And the reason we swapped the name to mag is so that we didn't need to write timer.py every time we wanted to start the program. We just wanted to write something simple, 3 letters, mag. We know what that means, we know what it stands for, and that's our tribute to the 20th anniversary of Phantasy Star Online episode 1 and 2. So once this timer reaches 30 seconds, we'll be given a visual warning. Then once it reaches 1 second, we'll be given a 20-second alarm, which will stand as our feeding time. It will then clear the screen, reset the timer to 193, and play the starting sound, and repeat for as long as we want. So this is hopefully the program in its entirety. We can have a look at the functionality that we've implemented. All of the features are now in. We've given everything we could to this project, and I'm pretty sure it works, but we're gonna see it through all the way to the end. Everyone who's been watching, thank you so much. It's been a real pleasure to be live and streaming this, sharing my basic programming with you. I love doing passionate little projects like this, and there'll be much more in the future. So once again, look out for that, and thanks for being around. So let's see this program through to the end and do the wrap up. So we're going to get rid of this timer.py file, which we just don't need. And in our mag timer, we should now just have sounds and mag, and we can git add all of that and git commit. Just git commit. So added clear screen implementation. We don't use this past tense. Add clear screen implementation. Adjust timer values to true 3 minutes and 15 seconds. Cool. Time is about to hit 30 seconds, so it visually warns us that there's 30 seconds to go. Get ready to feed me. That will stay on the screen. There won't be any of this other numbers ticking coming up, and it will be there waiting for us to feed our mag at 30 seconds from then. And once we feed our mag, the alarm goes off, we feed our mag, and then it will clear the screen and reset. Fantastic. There's one little adjustment I'd make, and that seems to be the 192 second, the starting jingle isn't happening for some reason. So let's go into our CD, to where our mag currently exists, home/bin, and we're going to make the change there. So we clear the screen and reset the timer to 194, and if seconds equals 193, okay. I'm not sure why we I'm not sure why the timer started at 192. But hopefully this doesn't give us any problems. We called clear and then we reset seconds to 193. So let's give this a go. So we've changed the numbers to 19 and 20 just for testing purposes. Ah, right. That's it. That's exactly it. Ginger tonic. The reason that happened, that the timer went to 192 and skipped the 193, which works now, by the way, is because in our while loop, after the second resets to the top, we then immediately sleep for 1 second and minus 1 second away. So the second reset becomes -1. So in order to deal with that, we just need to reset seconds to 194. Cool. I'm gonna push that up to GitHub, make the changes. I'm pretty sure that works now, so once we find out that this works, we'll copy this program which we've modified at bin back into our local environment, local repository, add all the changes, commit the changes, and push it up final to GitHub. The GitHub will be professionally adjusted so that the README looks good and everything. and it will all be there, and I'll send you guys all a link to the GitHub profile now, so you can have a look-see if you like. Here we are. There's a link to the GitHub for this project. So everything we did today was live. We learnt a little bit on the way, and I hope that I was clear and helpful in the explanation of this basic timer program that I've coded today here for you for the 20th anniversary special event of my favorite game. Once again, we're just going to see this timer through to the end, and then I'm going to close up shop and wish you all a lovely and nice rest of your day. Keeping hydrated. The last thing we do need to do before we add any changes, we're going to have to copy this file over, but we're also going to have to get rid of this ticking number countdown, as we don't want all this number countdown. We just want the 30 seconds warning. Fantastic. I'm going to get rid of the countdown, so this print function here will take care of that. We'll save the file, exit, copy the file from here into projects and into mag timer. We're going to navigate into that same. I'm going to check it's there. We're going to check that it's the same one, and it is indeed the same one. Great. Alright, git status. So we've modified mag. We're going to add it. We're going to commit, change, modified timer values, and clear screen implementation, and we've also removed print seconds function. And push that up, and that brings us to a close for today. Thanks a lot, and I'll see you out with some music. Have a nice time. Bye bye.
Thank you.